Okay, so this video goes over how to use analog and digital sensors. So, got a bunch of notes right here, very important. So we have two types of sensors in Botball that the robots can use, analog and digital. Digital sensors output either 1 or 0. So those are going to be buttons because buttons only have on or off. Analog sensors, they output a wide range of values from 0 up to even 2,900. So they're very versatile and I think they can give you more complex outputs. So the digital sensors are any button because buttons are only on or they're off. When they're off, they output 0, and when they're on, they output 1. Analog sensors, there are a couple different types. We have the light sensors. We have reflectance sensors, which just look at the ground and detect how much light is being reflected back. And then we have the rangefinder, which detects how far away something is from it. And then there's the camera, which is the most complex analog sensor, which it'll have its own video. But these are the sensors that you can use and plug into your robot. And if you want to call the value of any of the sensors, whether it be analog or digital, then you just use this format. You say analog, open parenthesis, and then which sensor port you want to use. So there's 0, 1, 2, 3, 4 for analog, or 5. And then there's digital, and you just say digital and then which sensor port, and there are more sensor ports open for digital. So, and then it's important to know that any digital sensor can fit into any digital port, and any analog sensor can fit into any analog port. So that makes it easy. All you have to know is whether it's a digital or analog sensor, and then you just have to know where the ports are for them. This is really important because if you're going to ever use any analog sensors which output a range of values, then you'll need to know what values you're looking for. And in order to do that, you'll have to plug in your sensor to plug it into the Wallaby, to the brain, or whatever brain you have for Botball, and then you'll have to go into motors and sensors, and then go into the sensor list, which is all right here. And then depending on which port you plugged your sensor into, the values of that, output on the screen of the brain will change depending on what you do to the sensor. So if it's a distance sensor, then if you plug the distance sensor in to port 0, and then you go to the sensor list in the brain, you can change, what that sensor is reading. So if it's distance sensor, you put your hand close to the distance sensor, the sensor list is going to output one value. If you move your hand further away from that sensor, it's going to output a different value. Same for the light sensor. Plug in the light sensor to analog port 0 on the brain. Go into the sensor list. If you put your fingers on the sensor, the sensor isn't going to see any light, and it's going to be one value, which is, I think it's a lower value, so around 0 for the light sensor. And then if you take your hand off, it's probably going to see the light in your room, and so that value is going to go up. So you'll have to do some experimentation on that. Here are some examples of how to use all that. So we have first we're going to be using a digital sensor, whatever that might be. It's a button because digital only has 0 or 1, and that sensor is plugged into port 0 on the brain, and we're checking if the digital 0, if the button equals 1, which means if it's pressed, because if it's pressed equals 1, then we're going to print to the screen the button is pressed. This right here just prints text, and you just do this and you put whatever text inside of these quotes that you want, and then it'll actually make a new line for you, so you can put as many as you want without it um, like gathering up on the screen. It's a really good way to print text to the screen. So if the button is pressed, then it will print this. Simple. So this is a while, and it says while the digital, which the button in port 1 is not pressed while it's 0, then you're going to print this over and over again. The button is not pressed. And if you just plug that button into the brain and run this piece of code, if you just had this right here, it's going to print this over and over and over and over again, infinitely, until you press the button, and then it'll exit the while loop. I put this here because if that wasn't there, then if I just did that, then this would go as fast as it can over and over again, and it would actually crash the brain. So you don't want it to do it infinitely quick. You want it to have a little space in between, so it goes boom, 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 instead of brrrr and overload the brain. That's a side note, but this is just a really good thing to know. And then this while loop right here, now we have analogs. While the analog in the fourth port, which is port 3, is giving a value that is less than 2000, then you're going to print still dark. So I made this an example of the light sensor right here. And so if I plug the light sensor into the fourth port, which is port 3 of analog, light sensor is an analog, and since if it's dark, then the light sensor is going to give a small value, and if it's bright, the light sensor is going to give a big value. So if the analog is giving a small value, which means it's dark, then it's going to stay still dark. And I put that in sleep again so it doesn't overload the brain. And then when it exits this while loop, which means the light sensor is going to give a value of 2000 or more when it exits, then the lights have to be on because it's greater than 2000. And I'm just saying 2000 because I'm guessing, that's about the part, say probably more 1000. When it gets over 1000, then the room's going to brighten up. And if it's less than that, the room's probably dark. All right. So, and then our last example right here, while analog 2, while the analog sensor in the third port is less than 1500, then you're going to move the left and the right. I'm saying the left motor is 0 and the right motor is 2. You're going to move them at 100 ticks per second. It's the motor position is measured in ticks, so this is just how fast it's moving. It's kind of slow, but it's a good speed. So whatever the sensor is, while it's less than 1500, then you're going to move forward. And I was thinking of, oh, well, what if this analog sensor is a distance sensor? So if something, say, is far away, it's a small number, and if something is close, it's a big number. So while this distance sensor is looking at something that's far away, so it's smaller than 1500, then you're going to keep on moving forward, and that number is going to get bigger and bigger and bigger because you keep on moving closer, but it's still less than 1500. And then it gets close enough and that the reading of this sensor, it gets to 1500 or bigger, and then it's going to exit and it's going to stop. So based on the readings of the sensor, you can get the robots to do different things. Or I could make this turning. See this, the wheels are going in opposite directions, so this could be turning while this, what this sensor is reading is less than 1500. This right here is for the small robot. Small robot. I could make this for the Roomba. I could say, um, what is it? Create drive direct, and I could say 100, 100. And this is just code for the Roomba saying move forward, move the left motor 100 speed, and move the right motor 100 speed while the analog is reading less than 1500. So based on, you can use some logic with the whiles and the ifs, and you can put the digitals and the analogs in there, and you can get movement in there also. So all these things, it's actually really simple as long as you're plugging the sensors into the right ports. Make sure if you plug an analog sensor into the first port, then say analog 1, because that'll get the read from the first port. So this is it right here. So there you go.